Hello. Reference video time. Let's go. So today we are going to be reviewing partial fractions. There is already one video on this, but I'm just gonna make another one just so this one's a little bit more clear than the other one in simplistic and everything. So to start off, we just to review real quick, just like some basic integration. So we have, like, for instance, integral of x squared dx is x to the third over 3. Why is that? Because if we differentiate x cubed over 3, we bring the 3 out, so it's 3x squared over 3. Those two cancel, so it's just x squared. So same with x cubed. If we started with x cubed, integral of x cubed dx is x to the fourth over 4. Why? Because differentiating x to the fourth over 4 gives us 3x to the fourth over 4, or sorry, 4x to the third over 4, cancel them out, so that's x cubed. So for a general case of an integral with the integral to x to the n dx, in general case, is x to the n plus 1 over n plus 1. Why? Because if we differentiate x to the n plus 1 over n plus 1, we get n plus 1 x to the n over n plus 1, which is just x to the n. That's if there's multiple components in an integral, so say we have the integral of 5x squared plus 7x cubed dx, we can split that because they're being added. So we can split it to the integral of 5x squared dx plus the integral of 7x cubed dx. Move the 5 and the 7 to the front. We have 5 integral x squared dx plus 7 integral x cubed dx. And then we integrate. So we have 5x cubed over 3 dx plus 7x to the fourth over 4 dx. And that's our answer to that one. What about fractions? Say we have the integral of 1 over x squared dx. We can write this, so what we can do is using exponent rules. 1 over x squared is actually x to the negative 2. Why did I write n? X to the negative 2 dx, which is then, if we add 1, n plus 1, it'd be x negative 1 over negative 1. Now, real quick, special case. This strategy up here of using the n plus 1 over n plus 1 works in every case except this one. The integral of 1 over x dx. Why is that? Well, because if we do the exponent rule, we have the integral of x to the negative 1 dx. But if we add 1 to both, we get x to the 0 over 0. You can't divide by 0, so this is undefined. Now what we can do, what if we subtract it? So if we have 1 over x minus 1, how we would do that is we would do a u substitution. So u would be x minus 1, which makes du over dx 1, which means that du, canceling it out, is 1 dx. So that makes it the integral of 1 over u du, which turns out to be the natural log of u, sorry, I'm running out of space here, natural log of u, which is the natural log of x minus 1. New page. You can start talking about some partial fraction applications. So we're going to be solving this problem here. We're going to have the integral of 1 over x squared minus 1 dx. Now, here's the thing. How do we start? Well, we can't use a u substitution. Why is that? The reason why, let's solve it and you'll see. So we'll have u equals x squared minus 1, which means that du over dx equals 2x, which means that du is 2x dx. So that makes du over 2x dx. Now if we plug this in, we get the integral of 1 over u du over 2x. This doesn't work because we can't have any more x's. It can only be u's. So since there's one x and no other x's, then it's impossible to solve. Or at least it'll give you some weird answers. Now how do we actually solve it? Let me rewrite it down again. The integral of 1 over x squared minus 1 dx. So, the first thing that we can do is split x squared minus 1 into x plus 1 and x minus 1 dx. So now I'm going to do some little side calculations over here. So, with partial fractions, we have 1 over x plus 1, x minus 1. Then we also have, here's how we're going to solve this. We have a over x plus 1 plus b over x minus 1. This is how we're going to split it. Multiply all three terms by x plus 1, x minus 1. This cancels, this cancels, this and this cancels. So that leaves us with 1 equals a x minus 1 plus b x plus 1. Now we combine the two. Now we multiply it out. So we have 1 equals ax minus a plus bx plus b. And then now we're going to combine the x's and the non-x's. So we have 0x plus 1. We need to add that there. Equals a plus bx plus negative a plus b. And now we put it in a linear system. So we have linear system. A plus b equals 0. Because you see how this is written. This is equal to this, and this is equal to this. So we know that this has to be 0, and this has to be 1. So we can finish writing this out, like such. And now, we start to solve. The first thing we're going to do is move the a to the other side. So we have b equals negative a, minus a plus b equals 1. Then, made that 2 way, this should be 1 wide. Negative a plus parentheses negative a equals 1. So that means that negative 2a equals 1, which means that a is negative 1/2. Plugging that in to b equals minus a, and we see that b is 1/2. Which means that we can go back up here and fill this out in our equation. So we have equals the integral of negative 1/2, because that's a, over x plus 1, plus 1/2 over x minus 1 for b dx. Now we pull these out front and split the integral. So we have negative 1/2 integral of 1 over x plus 1 plus 1/2 integral of 1 over x minus 1 dx. And finally, for the last step, as we saw in our first problems, 1 over x plus 1 is the same thing as the natural log of x plus 1. So we can finally finish out this problem with minus 1/2 natural log of x plus 1 plus 1/2 natural log of x minus 1. And that is our solution. Bye.